we're going to be doing some work on the front forks on the new Triumph Street Scrambler. Street Scrambler basically had the same forks as all the other Triumph Hinckley twins. You know, they're very basic, the forks, in the way they're constructed. They just have fixed compression and rebound damping. Now we're going to address that by putting some adjustability into the damping system on them. We're also going to increase the fork travel on this bike. We're going to put some adjustability on the spring preload, and we're also going to put some progressive fork springs in. So we'll go to the bench now, and I'm going to show you what the standard forks look like inside and what we're going to do to the internals to improve the way they perform. Okay. Okay, so we have a typical one leg side of a Hinckley Bonneville fork here. So it's all stripped down. Now, just to show you how everything works in the fork. Now, all the Hinckley twins are basically the same fork, 41mm. The only differences between them tend to be this casting on the bottom, have different lugs or mountings for the mudguards or whatever. The stanchions vary in length from model to model, as do the springs. Other than that, they're all basically the same internals. Now, the damping on these is handled by a fixed damping rod. Very basic. This design of fork's been around for many years. Not very sophisticated at all. Most modern performance bikes now use what's called a cartridge system, which allows fine tuning of the damping. This has compression and rebound damping, but it is not adjustable. The only way you can adjust it is by changing the viscosity of the oil in the fork. The problem there is, if you change the viscosity, not only does it change the compression damping, it changes the rebound damping as well. So you cannot fine tune it at all. Some people change damper rods. You can get, by changing the holes in the damper rods, you can change the characteristic a little bit, but it's still fixed and you can't fine tune it at all. Now, the easy way to this is there's several contraptions in the market called emulators. Now, they're called emulators because they emulate the action of a cartridge fork, in which, as such, they give a high-speed compression damping adjustability. Now, I like to call them high-speed compression damping adjustment valves, because that's effectively what they are. And it's basically this little gizmo here. Now, what this does is, this is your damping rod here. It sits on top of the damping rod. Now, your compression damping on the damping rod is handled by these holes here. As the fork is compressed, the pressure in the bottom chamber goes up, so the oil's forced through these holes here. Now, that's fine, it will give you damping on compression. The problem is, when you hit a hard bump, there's no sort of relief for the pressure at all. It still has to go through these holes. So this is what gives you the harsh ride when you hit a bump. Effectively, this hydraulic locks. It turns into a rigid rod, and it feels like you're riding a bike with no suspension. That's the problem. You get a real ouch when you hit a bump. Now, the answer to this is, we drill these holes out. We drill another set of holes, about 12 millimeters, centers up from these ones here, and then 90 degrees to these holes. In between them, at 6 millimeters, exactly between them, we drill another pair of holes. Now, we've then got 6 holes. We then enlarge these holes out in stages, drilling them a stage at a time, until you've got 6 10mm diameter holes. That effectively removes these holes from the equation. They're not having any significant effect on the damping on the compression side. Rebound damping stays as it is, which is controlled by this little bleed screw here, and the leakage that you have on rebound between the one-way valve in the bottom of the fork stanchion here and this damping rod, you get bleed past. Now, that's what gives you your rebound damping. Now, you can change the rebound damping by changing the viscosity. Obviously, lighter oil will give you faster rebound damping. Heavier oil will give you stiffer rebound damping. So, with this in place, as this has no more control on compression damping, all the oil comes up through here on compression, and this little valve sits in way. Now, what this valve does, it has a small bleed hole in here. That gives you your slow speed compression damping, the oil weeping through this little hole here. But when you hit a high bump, this little valve, this black disc here, pushes against the spring and opens a much larger valve in here, and it's the amount it opens is directly proportional to this spring here as well. Now this spring is adjustable for preload. You slacken this, check nut off here, and you can wind it in and out. Now they're normally supplied with about two turns of preload on them. On a higher speed reactant fork, I like to put about one or less than about half turn of preload on it, and then lock it back up again. But that's the adjustability. You can set that to whatever you want. So these are supplied as fitting Triumph forks by the manufacturer, but they don't fit properly. I don't like to fit them as they come, because this edge here doesn't fit inside the fork damping tube, and it doesn't fit properly on top either. It sort of just fits on the edge, and it doesn't seal properly because it'll batter around and can actually damage the damper rods. So this little silver part here, we make a spacer for them so that it actually fits properly against the top of the damper rod and seals. So with this in place, we now have high speed compression damping, and compression damping and rebound damping are independent of each other, because you can adjust your compression damping on this and you can adjust the rebound damping on the viscosity of the oil and compensate for the viscosity of the oil with this valve. So I hope that's clear, but we'll go into that a bit more later. Right, next component up the line is your fork springs. Now these are a standard Triumph spring. As you can see, they're linear, in which means that they're wound the same all the way up. They're not a high performance spring, they're just a Billy basic linear spring. Now there's many schools of thought. Some people like linear springs because it takes another thing out of the equation, makes them easier to tune. But we've had years of using progressive springs, and we just like the way they perform. Now progressive spring, we've gone into this before, but basically what it means is you have springs that are tighter wound here, and then they get wider apart as we go up. So what happens here, the spring doesn't really change its rate. A spring is a spring. It's all the same metal all the way up, it doesn't change at this end. What it means is the preload on the spring, or the amount of turn that you think of it as a torsion bar. At this end, you've got about 45 degrees torsion on the spring before it gets to the point where it's not effective anymore, and then it transfers to this one where you have about 90 degrees of torsion on the spring. So therefore, you've got effectively more preload on the coil. So that's what gives you a progressive nature of the spring. This part's used up first, then it moves on to this part. This gives you a much more progressive, hence the progressive spring nature, feel to the fork. You get a softer feeling at first, getting harder and harder as the spring compresses. Next, we move on to how we're going to extend the travel on the fork. Now, the effective travel on a Triumph fork is not great. It's probably okay for most road use, but for off-road use it's not fantastic. I'll pop this back in the fork tube where it lives, and as you can see, that's your travel there of what you've got on the fork. Well, it's less than that actually, because when the weight's sitting on the bike, it sits about there, and it's got about that much travel. That's how much you've got. It's not a huge amount of travel. Like I say, it's quite adequate for most road use, but if you want to go off-road, most off-road bikes now are running about 12 inches, motocross bikes are running 12 inches of travel. We've got about 3 there. So what we've done, we've made a couple of spacers up for the bottom here in longer bolts to give us, they actually sit in this little valve on the bottom here. And that effectively extends our travel by 30 millimeters. So we've got all of that now. So we've got almost a third more travel on the fork, between a quarter and a third more travel. Now we don't use all of that as compression. I know I like to have a bit more rebound travel as well. So it'll be run somewhere in between, sort of about raising the bike about sort of 20 to 25 millimeters from stock. And that will give you a little bit more rebound and a lot more compression travel. Now the reason of that is you want for your suspension to work properly, you want your wheel to be on the ground all the time. So as the ground drops away from the front wheel, it needs to be able to drop into that depression and not just go up against the top out spring, because if your wheel's not in contact with the ground, you can't steer and you can't brake. So that's what makes the bike controllable. So, and it's trying to keep the bike with the wheel in contact at all the time, so you can get traction, braking, or whatever. And that's the secret of suspension, really. It's all a compromise. Everything you do in a suspension is a compromise, but there's ways you can get much more fine tunability in trying to get the horrible, nasty ouch sting of when you hit a bump out of these forks. Right, the other thing we're going to add to these forks for fine tunability, other than the progressive springs, is the springs go in after the emulator valve here, and then you've got your spring spacer on the top. Now we tend to use these on the top. That's your stock fork top, which is obviously just a dumb nut that sits on the top. Whereas these will actually screw in and out, and you've got that much adjustment of how much preload, or effectively ride height adjustment you have on the bike. Now these will screw in out, I think it's 15 or 16 millimeters off the top of my head. So you can adjust the preload, like I say, or ride height adjustment, as you want to call it, on the bike of between 15 and 16 millimeters. Now that's great for setting the bike up for the attitude of the bike. It doesn't sound a lot, but that changes the attitude of the bike by a huge amount. Now obviously, because this is sitting under the spring, the thickness of this has to be taken into consideration, and also what I like to do is take about half of this into consideration when you're setting up your spring spacer here. Now obviously when you build the fork up, you're going to have a look what the preload is on the spring and compensate for it by cutting the spacer to the right length to live with these two components that are going in the fork. But we'll do that as we go on building the fork up, when we get them stripped up. Well, we'll get the fork stripped on the bike. So that's about it for now. We'll get onto the bike and we'll show how it's done on the bike. Now we're going to do it all on the bike. We don't remove the forks from the bike. As you know from my other videos, I like to do things the commercial way, the way it's done in the workshop, the time-saving way. Because time is money when you're in a workshop. And the other thing about taking forks off a bike, you're much more likely to damage them because they're quite hard things to hold. Unless you've got some sort of clamp to hold these. Most people don't. They try to hold them in a vise. Now you clamp this in a vise and you measure them with verniers. You put a tiny amount of pressure on here and then distort. And they distort quite a bit. And you need to hold them quite firmly so you can undo the nuts and the damper rod and things like that. So it's much easier when they're clamped in the yokes. They aren't going to damage the forks, and you can get on to loosen everything off. Right, tools required to do this job. You're going to need an impact driver to get the bolt out of the bottom of the fork here, because there's nothing holding this in. There's only the friction of the spring holds the damper rod in place, and what it'll do is if you try using an ordinary Allen key, this will just turn in the fork rod. So you can buy special tools that lock the fork rod, but ask like most people in the trade, and all they ever do is leave the spring in place, pressing down on here, and stick either a windy gun or an electric impact driver with a socket on the bottom, and it'll wind out. If it just turns a little bit and sticks, wind it in and out a few times and you'll find it'll eventually come out. Like I say, last case you'll have to resort to is the tool that goes inside of here and locks it up. You can actually make one yourself out of a couple of bits of tube with a bit of threaded bar with slash cut, so it works a bit like bar ends on a handlebar, so when you tighten it up it locks up in here and grips it tight. And effectively all you're doing is stopping this from turning. But normally the pressure of the spring and the forks being built up in a windy gun will allow you to get that out. But if you want to just use an Allen key, good luck to you, because 99% of the time it won't come out. So you're going to need to beg, borrow or steal some sort of impact driver to get that out. The rest is all basically conventional tools, and like I say, you're going to need some large spanners for here, and for this I think one's 27 and the other one's 32, I think, depending on the model of the bike. And we'll get on the bike and show you how it's done. Like I say, we're going to show you a few shortcuts on how things are done. But there's a lot of variables that need to be done on the bike to take into account of things. And there's a lot of things you can adjust for setting up, but we'll go through that as we put them on the bike. Okay, so we'll move on to the bike now. I've taken the front wheel off and removed the front caliper. I've obviously got the bike supported underneath there. Now a little tip when you're using the windy gun on the fork legs, a lot of the time they'll come straight out just using the windy gun not as normal, but like this one here, I've put it in and it's just spinning. Now I've tried it backwards and forwards a few times and it didn't work. This one was the same. So a little tip, if you are going to fit the fork preload adjusters, just take the top out and put the preload adjuster in and then wind it in, and it'll put a bit of tension on the spring, and that's normally enough so you can get to come out there. It's actually not good enough so I can actually take it out by hand there now. So I don't want that out just yet because all the oil will come out, so I'll just wind that in finger tight. And what I'm going to do is I'm going to put that fork cap on that side now so we can get that tension out. Okay, so I'll do that and then we'll come back to it. Okay, so we've removed the bolt out of the bottom of the damper rod out the bottom, and we've drained the oil, and I've taken the fork top nut back off again. So we need to take the spacer tube out, and I've just laid everything out onto a piece of clean paper or cardboard because you don't get any dirt in here. And the next item to come out is the shim that goes on top of the spring. Then you have the spring. And then we have the damper rod. And underneath the damper rod, you don't need to take this out, but I'll take it out just to show you, is the top out spring. So I'll go and re-drill the holes in this now, and I'll show you what we need to do to put it back in all together again. Okay, so I've drilled the damper rod out, and it's actually 8mm holes. Sorry, I said 10mm holes earlier, but we put 6 evenly spaced 8mm holes in there. Now, very important that you actually deburr and file off these holes so you don't have any rough edges on there, because you don't want them jamming on the rebound damping valve. So clean everything off, use some solvent, brake cleaner or WD-40, and then use an airline or whatever just to blast them nice and clean, because you don't want any bits of grit or metal in your fork. So the tip for assembling the forks is, what I've done is I've passed a piece of M8 rod. You can use anything really as long as it's smaller than the actual rod, but I've just used a bit of M8 studding there, which is a nice size. And what we need to first of all do is put the spacer that we're raising the forks within on first, and that just slides down nicely. Then we put the damper rod, not forgetting the top out spring, that goes on next. Give it a little jiggle so it sits down there. Then we put the new springs in. And the new spring is exactly the same length as the old spring. And we put it with the tight coils at the top. Now we're not putting the emulator in at this stage because all we're doing is tightening the damper rod up. So we put the spacer tube and washer in. Now what we need to do is get the new longer bolt that we've made to go on the bottom with the original sealing washer on the bottom. That's important, otherwise it will leak oil. Now the rod that I put in is actually sticking out the bottom there, so it'll actually locate everything. So we'll just jiggle that and get it all lined up. And just put a bit of pressure on the spacer at the top. And As you're pushing it up, you actually just push the threaded bar out the way. Just get it started a few turns. And what you find once you've got it started, it'll probably stick a little bit in the threads and you're going to need a bit more pressure on the spring to get it to lock. So what you probably have to do at this stage, if you haven't got a locking tool, is to pop the top, pull the rod out and pop the top back on. Either the original or ideally what I normally do is put the adjustable top back on. So wind that back in and wind the adjustment down so there's lots of nice pressure on the spring. Hopefully if that all located in place properly. Just a matter of nipping it up with a windy gun. There you go, tight. Now what we need to do now is take the top back off, put the emulator in, and then we'll measure the well, we can't do that just yet actually. We'll do the other fork leg first, then we'll whip the top off, because now the fork leg isn't sitting against the top of the out spring because it's longer. So we need to get the other one off and do the other one first, then we can do the fork spacer lengths and the fork oil heights. Okay, so that's all the damper rods assembled up in both the forks there now. I've taken the springs back out and the spacers back out, and we need to put the emulators in now. Now they just go in with the bolt sticking up. Very important that you put them in that way up, because you'll have no compression at all. So they must go in that way. So you just pop those in, and they sit on top of the damper rods. Now before we put the springs in, we need to set the fork oil height. Now the fork oil height on this particular model, I mean you can check it with your workshop manual, but it should be checked with the fork fully compressed and filled with oil, but make sure you pump it up and down a few times first to get any air bubbles out of the system. Now the standard height is 170mm from the top of the fork. Now I like to run a little bit less for off-road, and you get less of an air compression spring effect on here. So I'm going to run it about 20mm less. So that's 190 from the top, right, but 20mm more from the top, sorry. So 20mm less oil. So the measurement from the top of the fork to the oil, fully compressed, will be 190mm. But if you're reducing your oil, always make sure that you've got full damping all the way through the stroke. Now remember that when you put your springs in, it will raise the oil level a little bit as well, so just compensate for that as well. So I've filled the fork tubes up with oil now, and I've put the springs, the emulators, the springs, spacers and the washers in. Now I've shortened the spacers by 28mm. That's to allow for 20mm for the emulator and 8mm to have a centre range adjustment on this at normal ride height. So you see they sit a little bit lower in the threads and the tubes than the originals did, but this will allow me plus and minus adjustment on here. So it's just a matter of bolting both of them up there now. Now an important thing to note, if you're extending any forks on any bikes, I mean this method will work for most bikes, is that your brake pipe, I mean that's fully extended there now, and the brake pipe will still reach without pulling. Now it just reaches on these, the extension I put on. If you want to go any longer, you're going to have to put a new brake pipe on. I'll try this and see what it's like. I may have to put a new little guide on here to stop it rubbing the mudguard, but we should be okay with that. But be very careful of that, because if you don't extend the brake pipe and the front end goes light and pulls the brake pipe out, the next time you pull the brake you might not have a brake. So that's something important to check, very safety conscious. So this is just a matter of assembling everything back up now, and once these are tightened up, I'll put these to middle adjustment, and we should have a front end lift of about 1 inch, if everything being equal. So that's it all installed there now. As you can see, it's sitting a lot higher at the front end now. It's amazing what difference 1 inch makes on the front. You can see how much is lying over on the side stand now. Now I'm going to play about with the settings a bit and get the damping just how I like it before I change the rear shocks. I'm putting shocks on the rear end set at about 15mm longer than stock, and that'll I can play around with the length on that and the preload and the overall length. So I'm looking at around between 15 and 20mm at each end, raise over stock, and it looks like I'm going to have to put an extension on the side stand a little bit just to stop it lying over too far. But we can soon do something with that. We can screw something to the bottom of the side stand, just a little foot onto it. Probably wouldn't hurt for soft ground if we can put a bigger foot on the bottom of the stand anyway. But it's solid alloy, the side stand, so we can just drill and tap it and put a little foot on there. Can't wait to give it a try. It's getting a bit dark now, so I'm going to wait until tomorrow to give it a try. And like I say, we've done plenty of these before, but this is the first one I've done on a street scrambler. Now you can do this conversion, you can do any part of the conversion, you don't have to do all the parts that I've done. You can fit just the springs and the fork top adjusters if you want to do. That's the most popular thing that people do. Or you can fit just the emulators and drill the damper rods. Or you can fit just the extension part, but I wouldn't recommend doing that without doing the other parts. Now, like I said, one of the most important things you need to watch out for with doing the extension, I've actually scaled it back. I did have a 30mm, I've gone down to 27mm on the extension pieces, basically because I didn't want to push my luck too much with this brake pipe. It looks fine there, but when the forks are fully extended and pulling hard on the top out springs, hence wheelie, you know, if you're wheeling the bike or going very light on the front end over a humpback bridge or something, it's getting to the point where the brake pipe is just a little bit tight. So I'm going to have to make some sort of guide for the pipe here, and if I want to go any longer I'm going to have to change the pipe because it wouldn't be long enough, just for safety's sake. But that's something just to watch out for if you're doing an extension. Like I said, just the emulators alone, or the fork springs on their own, or any combination of the three you can do. It's just I thought I would do all three and show you how it could be done on the bike. It's taken about an hour and a half to do it all by the time we drilled the parts, and I think it takes a bit longer when you're doing a video, but yeah, it's not a bad job on the bike. It does save a lot of time and a lot of messing about taking them off, and it minimising the chance of doing any damage on there as well. So the next video I'll have the rear shocks on, and I'll give you a full report on how the bike's going with all the other mods we're doing on it. Okay, thanks for now.